Okay, good evening. Here's Unit 8A, Lesson 2, Day 2, the video notes for slope. We have our same learning targets, and we have some definitions that we have to take care of. So, this is a rate of change. Rate of change compares the change in one quantity to the change of another in another quantity. Another name for rate of change is slope. We know what slope is. That's whenever you see the phrase rate of change, you think slope. Okay? So finding the rate of change or finding the slope. I could say slope right here. So 3 steps. A, we choose two ordered pairs from the table. Then we use the slope formula to find the rate of change. Then we label the rate of change with the appropriate units. So let's look at number 1. Table shows the cost of using a computer at an internet cafe for the given amount of time. Find the rate of change. Well, they're asking me to find the slope. I know that. So I could even cross rate of change out. Find the slope in cost with respect to time. I'm going to find the slope. We're going to have our table. We've done this before. So I need to choose two ordered pairs from the table. Well, my input, that's my x's. My output, cost is the y's. So this is x1, x2, y1, y2. Just got to match the little ones up. This is x1, this is y1. This is x2, y2. We could use that other one if we want. So my ordered pairs are going to be 2, 7, and 4 and 14. So 2 and 7, 4 and 14 are my ordered pairs. Now, use the slope formula to find the rate of change. Slope formula. Another word for another rate of change is slope. I know slope is m. The change in cost, so the change in y over the change in time, the change in x. Or y2 minus y1 over x2 minus x1. That's all we're doing. So y2, 14 minus y1, 7. 14 minus 7 over x2 minus x1. x2, 4 minus 2. 4 minus 2. 14 minus 7 is 7. 4 minus 2 is 2. If I put that in my calculator, I get 3.5. Okay, that's B. C says label the rate of change, so label the slope with the appropriate units. The rate of change, or the slope in cost, is, it's money, $3.50. I'm going to add a 0 because that's money. $3.50 per hour. You just got to put units on there. So number 2 is a U try. Just a little hint. The units down here are going to be miles per minute. So miles slash minutes, whatever number. So try 2 at home or in class tomorrow. 3. Show you how to do this one. It looks like a really tough question, but we'll make it easy. So the rate of change for two functions are being compared. One function is represented by the equation f of x equals 5x minus 2, while the other function g of x is represented in the table below. So this is g of x, here's f of x. Which statement is true about these functions? The rate of change of f of x is greater than the rate of change of g of x. The rate of change of f of x is equal to the rate of change of g of x. This is getting confusing. So the rate of change, what are they looking for? Slope. So the slope of two functions is being compared. Okay, that sounds better to me. I can find slope. Let's change these. So the slope of f of x is greater than the slope of g of x. Or the slope of f of x is equal to the slope of g of x. Rate of change, slope, same thing. The slope of g of x is greater than the slope of f of x, or the slopes cannot be determined because f of x and g of x are not linear functions. So I just rewrote that to make it a little bit easier maybe to understand. So we just got to find slope. So So f of x, I got to find the slope of f of x and compare it. Is it bigger? Is it equal to? Or is it less than g of x? Is g of x bigger? Or can we not find it? Well, we can find it. It's a linear function. If I don't have an x squared there, it's a linear. So it's not d. So how do I find the slope of f of x? Well, we talked about our slope intercept form is y equals mx plus b. M is the slope. It's the coefficient of x. So the slope here of f of x is 5. Halfway done. I found the slope of f of x. Now I got to find the slope of g of x. It's a table of values. Instead of horizontal like this one, it's just up and down. So we can do this. Here's my x1 and my x2, my y1 and my y2. So I want to find the slope. M, the slope, is y2 minus y1 over x2 minus x1. So y2, 3 minus 5. x2, 0 minus a negative 4. 3 minus 5 is a negative 2. This turns into a positive. So it's a 4. 0 plus 4 is 4. Negative 2 over 4 reduces to negative 1/2. So, slope of g of x is negative 1/2. Slope of f of x is 5. Just rewriting it. So, which one's bigger? F of x. 5 is bigger than negative 1/2. Let's see. The slope of f of x is greater than the slope of g of x. Yep, that works. Let's just make sure the other ones don't. The slope of f of x is equal to g of x? No, 5 is not equal to negative 1/2. That's not it. The slope of g of x is greater than f of x? Nope, negative 1 is not greater than 5. Nope, and we already said it's not D. So answer is A. Seems like a tough problem, but we can do this. It's just finding slope. One of them, you're just looking at that coefficient. The other one from a table. So 4 is a U try. You guys try that. 5. Let's see, the rate of change. Well, the slopes, the rates of change. The slopes of two functions are being compared. One function represented by f of x is negative x squared minus 5, while the other is represented by this. Okay, which statement is true? Well, I know that says the slope of f of x is greater than g of x. The slope of f of x is equal to g of x. The slope of g of x is greater than f of x. The slopes cannot be determined because f of x and g of x are not linear functions. So we got an easy out here. Since that's an x squared, it's not a linear function. It's a quadratic. So, answer's D. That's not a linear function. We cannot find slopes unless the function is linear. Unless it's just an x. If it has an exponent, you can't find the slope. Okay? We'll talk about that one in class tomorrow also. Alright, number 6. 6, 7, 8, and 9. These ones take a little bit of work, but we just got to find some slopes. So, which of the following tables represent a function with a constant rate of change or a constant slope? So, meaning the slope is the same. So, I'm going to look at each one of these, and I'm going to look at this ordered pair compared to this. So, how do I find the slope here? Well, it's y2. Let's say this is y2 and y1. So, negative 11 minus a negative 15. All over x2, negative 11, minus a negative 13. What does that equal? This changes to positive. Same change, right? So negative 11 plus 15 is 4. Negative 11 plus 13 is 2. Simplifies to 2. So the slope between these two ordered pairs is 2. They want to know if it's constant throughout the whole thing. We got to check each pair. So I did one in first pair and second pair. Now I'm going to do the second pair and the third pair. I'll put an arrow down here. So, negative 5 minus negative 11. y2 minus y1. I'm just changing, doing those two pairs. over x2, negative 8 minus negative 11. Same change. So negative 5 plus 11 is 6. Negative 8 plus 11 is 3. 6 over 3 is 2. They're the same so far. I got to check them all though. So I check the first and the second. I check the second and the third. I'm just going to do it over here. The third and the fourth I'm going to check. So let's see. I got y2, 3 minus a negative 5. You guys are going to be experts by the time you do these problems. And then I have negative 4, x2 minus a negative 8. So we change. What does that equal? 3 plus 5 is 8. Negative 4 plus 8 is 4. 8 over 4 is 2. I got 2 here, 2 here, 2 here. Constant. I got to check one more pair. I'm going to check this pair right here. The third pair and the fourth pair, I'll do it right down here. So, y2, 9 minus 3 over negative 1 minus a negative 4. What does that equal to? 9 minus 3 is 6. This turns positive. Negative 1 plus 4 is 3. Slope of 2. This one has a constant rate of change or a constant slope. The slope is 2. It's constant. Number 7. Got to check them all. I'm going to check these first two pairs. So, 8 minus 5 over 0 minus a negative 3. 8 minus 5 is 3. This turns into a positive. 3 over 3 is 1. Okay? Let's check. I'll check the second one right over here. Put an arrow down here like this. So I get 14 minus 8 over 1 minus 0. 14 over 8 is 6. And this is 1. This slope is 6. 1 and 6, not constant. I can stop. I don't have to check anymore. It is not 7. Can't be 7. Doesn't matter if I check them all. If these two are different, it's not a constant slope. Each ordered pair has to have the same slope. And we can kind of see that these x's go down by, or go up by, they're constant compared to over here. So over here they're not. This is what we're looking at though. Alright, 8 and 9. You try. You try. So you guys try those. Okay? Do the same thing. You got to check each ordered pair. Once you find one that's not constant, you can stop. 10. So from 2003 to 2006, the amount spent on new cars increased at a relatively constant rate of $435 million per year. In 2006, $9,975 million was spent on new cars. How much was spent on cars in 2003? So, we could draw a little table here. Here's my time in years. Here's going to be my cost. So, I got 2003. Squeeze it in there. 2004. 2005, 2006. Okay, I just wrote all the years. It says the amount spent increased at a relatively constant rate. So we're talking about slope of 435 million. Let's leave that out for right now. In 2006, so if I was to do this table, in 2006 it's 9,975. How much was spent on the new cars in 2003? So I'm looking for this. How much was spent there? A couple different ways. I'm going to show you the easy way to do it. Tomorrow we'll go over the other way also. So we're going to do this in 4 steps. Step 1. I'm going to say in 2003 and 2006, I'm going to list my years. In 2003, I do not know how much was spent. In 2006, I know it was $9,975. Okay? Kind of looks like a XY chart if we really wanted to do it. My X's and my Y's. Okay? Step 2. Step 2, I'm going to subtract these years. So, from 2006, I subtract 2003. I get 3 years. Okay? Step number 3. I know that the change every year equals the change, relative constant rate. So the constant rate of change was 435. Was 435. So if I know my difference here is 3 years, I'm going to take 435 and multiply it by 3. When I do that on my calculator, scratch that out, I get 1305. Okay? So I know from here to here was 3 years, and this difference should be 1305. Every year I could subtract 435 from here, then subtract 435 from here and 435 to get that. This is the faster way to do it. So now I just need to subtract from 9975 minus this 1305 equals $8,670 million in 2003. And like I said, we could think about this a different way if we wanted to. Well, 9975, they said the rate of change is 435 million per year, so I'm going to subtract 435. I would get 9540. Well, then to get 2004 minus 435. 9105. To get 2003, I'll subtract another 435, and I get 8670, which is what I got over here. Okay? Do it either way. You can keep subtracting that rate of change in that table. They're just looking for this number. Okay? Number 11, you try just like this one. So you guys try that. We'll talk about it in class tomorrow. Last problem for tonight, number 12. So, in 2001, Jane purchased a house for $168,000. So, what we're going to do here is a little bit different. Let's see, in 2008, the house was worth $242,000. So, the house went up, right? Find the house's average annual rate of change. Rate of change. What does that mean? Slope. You're looking for the slope. In dollars per year. Round your answer to the nearest dollar. Let x represent 0. Let x equal 0 represent 2001. So, let's take a look at this. Step 1 for this one. Well, in 2001, the house was $168,000. In 2008, the house was $242,000. Okay? What if I made a little table out of this? Here's my X, here's my Y. I'm looking for slope, so I can use my slope formula. Step 2, slope. Y2 minus Y1 over X2 minus X1. So here's my Y's. This is going to be my Y2. So I say 242,000 minus 168,000 all over X2. 2008 minus X1. 2001. We do that on our calculator. You can do it on your calculator. This turns into 74,000. 242,000 minus 168,000 all over 7. Punch it in my calculator and I get 10 point, well here, I'll do that in my calculator right now. So, I do 7400, one more 0, divided by 7, and I get 10,571.4285. Well, wait, they said to round to the nearest dollar. There's my dollar. It's 0.4, so I'm just going to round it to 10,500. Whoops. And $71. So $10,571 per year. That would be my answer. Slope, rate of change, you got to have a per year, per something in there. So dollars per year. All right, 13's a you try. Fill out this, and I'm sure we'll have some questions tomorrow. We'll see you. Good night.